Hello, welcome back. We've been looking at designing classes using composition, or the has-a relationship. So we've been saying things like an address has a zip code, and a race car has a speed. And all of these, if you say them out loud and they make sense, then you have the right design. And that's why object-oriented programming is easy. So we're going to move from composition, where we decide what the instance variables are, to inheritance. And this is the way that we do design among classes, how are classes related to each other. And we have the same kind of a rule. With composition we add has-a, and with inheritance we have is-a. So if we say it out loud, a blank is a blank, and it makes sense, then you have the right inheritance design. So this is how classes are related to each other. And sometimes I try and sneak this in by explaining it to you and then telling you, well, that's inheritance, but it doesn't work too well in a video. So let's, I'll tell you that it's easy. And if it makes sense and it's easy, then it's right. If it doesn't make sense and it's complicated, then it's wrong. That's a pretty good kind of a problem to be working in. So the relationship is a, and if we say a dog is a animal, then we have the correct inheritance relationship, because I do believe that a dog is a animal. And other ones that you might say that a race car is a car. Some people use the expression is a kind of. So a dog is a kind of animal. A race car is a kind of car. So the properties in the animal class are inherited into the dog class. So for example, if we say an animal has a weight, how much does an animal weigh? So that would be an instance variable in the animal class. And then if you say a dog is an animal, and an animal has a weight, the implication is that a dog has a weight. And it makes sense. So if a dog is an animal, and an animal has a weight, then it does make sense that a dog has a weight. So it's really pretty easy, and if you say it out loud and it's right, then it's right. So let's look at some terminology of the relationship between these two classes, dog and animal. The parent class, the animal class in this case, is sometimes called the superclass or the base class. And the child class, or the dog in this case, is sometimes called the subclass or the derived class. And it just depends on who you're talking to, which of these expressions are being used. I try to use superclass and subclass, but I don't always. I turn out to be using parent class and subclass, which don't seem to match, but these things are quite interchangeable, and understanding which one is on the top and which one is on the bottom is all you really have to be able to do. One more point here. Java is a single inheritance language. That means that each class has exactly one parent class. And I do mean one. I don't mean it might not have any. Every class in Java has exactly one parent class. In the example we're looking at, the dog class has one parent, and that's animal. The reason that I'm making a big deal out of this is because other languages, most notably C++, is a multi-inheritance language. So dog could inherit from lots of different places instead of just one place. So they did this on purpose when they designed Java. They said C++ is really too complicated. People can write code that no one can understand, and we're going to simplify it. And it turns out that the language doesn't really lose anything except complexity. And people would argue that. It depends on what academic you're talking to. Let's go and look at some code. At least the beginnings of some code. So we know how to define a new class, a new data type, and I'm saying we're going to define a class called animal, and then we're going to define a subclass, and excuse me, what we say here is dog extends animal. So this is the child class or the derived class. Think about the keyword extends. Take everything that's in an animal and add some stuff to it, and you get a dog. So all the properties of animal, and then extend it by adding some more stuff, and you get something that's more specific than the parent. So a dog class could also be the parent of other classes. Think about what could go here. A greyhound is a dog. So now we have a greyhound class, which could be the subclass of dog, and dog is the subclass of animal. So it's not just one layer of inheritance. You can have as many layers deep as you need. And it's not just every class has one child. We could say that cat extends animal, and bird extends animal, and iguana extends animal. So we have an inheritance hierarchy, this being the root of the hierarchy and all of its children, and then each of those children can have a bunch of children, and it takes the form of a tree or an inheritance hierarchy. I'm going to go and type some code in Eclipse. I don't like to babble about this too much until I actually show you something, because I know you fall asleep easily, as do I. Let's go into Eclipse and just start typing an inheritance hierarchy. So here I am in Eclipse, and I made a new Java project, and then I made a test class inside of it, and I'm calling it test inheritance with a main method. So this program, this class, has the job of testing the classes that we're going to build using inheritance. So I'm going to go over here and I'm going to add a new class, and this class is going to be called animal, and it will be a very, very simple class. So what does an animal have? So it's instance variables. An animal has a weight, and we're going to fill in the rest of the class. It's a very simple class. It's just used for demonstration. So here's the constructor. When we make an animal object, we're going to specify the weight, and let's add the accessors and mutators using Eclipse. It will help us if we say source generate getters and setters. I would rather it called accessors and mutators, but that's okay. And it moved my constructor method down. I'm going to put it back up there. So I'm going to call the set weight and pass in the weight. We need a toString method. Yep. And our toString methods always look like that. And this is the way I do it: declare a result, return the result, and then fill in the middle. How about I'm an animal weighing and then concatenate on the weight. So the rule for the toString is that we return a string object that at least includes all of the instance variables. So there's nothing new here. This should have been more or less a typing exercise, and maybe I could have typed it without you watching me. But I'm going to go over here to the test and just make an instance of it. An animal, I'll call it my pet, gets new animal that weighs 12. And then I'll output my pet, just to make sure that everything is working the way we expect it to. I'm an animal weighing 12. So we output the object by just passing the reference to the object to the println method, and it automatically calls the toString method in that class. Okay, so nothing is new here so far. Here's the animal class. Now I'm going to go back to the project, and in the default package I'm going to say new class, and this time I'm going to call it dog. And I spelled it wrong. Well, darn it. Now I'm going to say new class, and I'm going to not make a dag, I'm going to make a dog. And so this is where it starts to be interesting. The first thing that we're going to do is we're going to say a dog has a name. Does that make sense to you? A dog has a name? So an instance variable will be private, and then all dogs have names, don't they? Well, we'll say they do. And now I'm going to make a constructor. No, the constructor will be public dog, and to make a dog you have to pass in a string, which will be the name of the dog. And I'm going to ask Eclipse to generate the getters and setters for the string variable. I probably should do that. Oops. Before I generate the getters and setters, but that's okay. So there's nothing new here. A very simple class that has one instance variable. A dog has a name. And now we're going to associate the dog class with the animal class. I forgot to call the setName method in the constructor. Sorry about that. I'm trying to rush, not to waste your time, and then making these little mistakes. So let's just be calm, and now we're going to associate the dog with the animal. So we don't change anything in the animal class. The parent class does not know about its children, but the child class knows who its parent is. So the dog class extends the animal class. So long as you put all of your classes here inside of the same package, they can all see each other. Now, something doesn't compile in here. When you make a dog that extends animal, what does it take to make a dog? Well, a dog has a name, a dog is an animal, and an animal has a weight. Okay, so to make a dog object, we have to specify two things. We have to specify the name and the weight. So I'm going to put weight here. So because a dog is an animal and an animal has a weight, we are going to pass into the constructor the weight of the dog. Now, it doesn't compile. Let's look at the message that's popping up. Implicit superconstructor animal with no parameters is undefined. Must explicitly invoke another constructor. Okay, so when you inherit from a class, the first line in your constructor must be a call to the parent constructor. If you don't put one there, Java will put one there for you. So here's what Java put for you. Super with no arguments. And that's why this won't compile, because the parent class does not have a constructor that takes 0 arguments. It does have a constructor that takes 1 int. Okay, so let's think about that for a second. The first line in the constructor is a call to the parent constructor using the keyword super. So the parent constructor, or the parent class, must have a matching constructor method, or it won't compile. This is tricky because the line of code that didn't compile before, you couldn't see it. The line of code was an implicit super call, an implicit call to the parent constructor. So that's a difficult bug to find if you forget to call the parent constructor. So let's think about what we've done here. It's not very difficult, but it's kind of profound in object-oriented design. We've created a class that has a parent class, animal, and we have inherited into the subclass all of the properties and the methods of the animal, the parent class. So if we made a dog object now, could we call the getWeight method from the dog object? Or the setWeight method from the dog object? We can, even though getWeight and setWeight are not in the dog class. Those methods are inherited from the animal class. So it's the job of the parent class, the one that has the weight variable, to maintain that weight variable. And anything that has to do with manipulating that variable belongs in this class. And all of that functionality can be inherited into this class. Let's go and prove that. Let's make a dog. Max gets new dog, and we're going to pass in Max weighs 34, and his name is Max. And now we can say max dot, what pops up? The methods that are in the dog class that start with S are setName, and setWeight is also available to us, and it indicates here that it's inherited from the animal class, the parent class. So we can call the weight class, and we can change Max gains some weight there, up to 56 pounds. Okay, back to the dog class. You should be screaming right now, you forgot to put the toString method, but I really didn't. I'm going to put it here now. Public string toString. And I just thought maybe I will use this as a teaching method, a teaching moment. I forgot to put the toString method in the dog class. What happens if I print out the dog? Let's just run this and see what it does. Well, it still works. We can print out this dog, but what it prints out isn't really too appropriate. It prints out, I'm an animal weighing 56. Do you see what happened? Some people might be guessing what happened now. The toString method in the animal class was inherited by the dog class. So does the dog class have a toString method? Yes, it does. It got it from the animal class. But it's not an appropriate two-string method. It doesn't print out the name of the dog. So what we're going to do is we're going to define a method that has exactly the same signature, public string, two-string, and we're going to make a two-string method that's appropriate for the dog class. Now what do I want this string object to give back to the caller? I'll just put dog, and I'll concatenate the name of the dog. I also want to put the weight of the dog, and I could write something like weighing, and then call the getWeight method, which we inherited from the animal class, and that wouldn't be too much work. But if the animal class, the parent class, had a whole lot of instance variables, I would have already written the code to output that in a nice way, or to present it in a nice way in a string object. So what I would like to do here is to call the two-string method that I inherit. So I'm going to say super.toString. The super keyword is kind of related to the this keyword. It's a reference to the parent object. Okay, let's think about what we did here. We inherited a two-string method from the animal class, but we don't want it. So we're going to replace it with one that looks the same. I call this the thanks but no thanks. And officially it's called overriding, method overriding. So we inherited something that we don't want, and this little green triangle on the left indicates that this method overrides the two-string method in the animal class. Let's go back to our test class and run it again. And what we find now is the printline method calls the two-string method in the dog, and it prints out dog max, and then it prints out the two-string the two-string from the superclass. A space would have helped there, wouldn't it? There. So we did method overriding. In the previous segment, we talked about method overloading. So we were talking about within a class, you can have more than one method by the same name, including overloaded constructor methods. Method overloading and method overriding are completely different. With method overriding, you must be inheriting something that you wish to replace or override in the subclass. So I want to go back to these slides for a second and try and hammer this one home. The constructor methods always call the parent class constructor as the very first line of executable code. If you don't do it, Java will put it there for you, and they will write the line of code super with parentheses and nothing in it, and that can be a syntax error that you don't get to see, because when Java adds this to your constructor, you don't see it, it's just there, and it might not compile. So if the parent class doesn't have a zero argument constructor, then the default call to the constructor won't compile. Okay, I'm sorry for saying that 4 times, but that is a real problem, and people will waste a lot of time on that. So for now, until you get used to it, always call super as the first line of your constructor, and make sure that you understand that you are, with that call, calling the constructor of the parent. So in this discussion of inheritance, I told you that in Java, every class in Java has exactly one parent class. And some of you should be screaming, but wait, the animal class and all of the classes that we've made up until now don't have a parent class. And that's not really true. They do have a parent class, but it's a default parent. So here's what Java adds for you. If you choose not to use the extends keyword, Java will put it in there for you, and I'm not changing anything by typing this. The animal class extends object, capital O. Object is called the universal superclass. Let's see if it makes sense. An animal is a object. Well, in fact, you could say anything that is a noun is a object. So that kind of makes sense that object has some things in it that are inherited by all classes in all of Java. So in our tiny inheritance hierarchy now, we have a dog is a animal, an animal is a object. You could also say that a dog is a object by inference. If a dog is an animal and an animal is a object, then a dog is a object also. In fact, the name of every class in all of Java, the ones that you can think of and can't think of yet, extend from the object class, and it's called the universal superclass. So that has been in all of the code that we've written up until now, but you just didn't see it. So just before in our discussion, I said that the first line in every constructor is a call to the parent class constructor. If you don't put it there, and we haven't been up till now, Java will put it there for you. And that's what it looks like. So by doing this, by putting extends object and by calling the parent class constructor, we haven't changed anything, and you can put that there if you want to, but it doesn't do anything, so you'll get tired of doing it after a while, and you'll just know that you are inheriting from the object class. Okay, given that, if you don't extend something, Java will extend object for you. When we go back to our test class now, and we have an animal object, if I type my pet dot, what pops up? Well, this has been happening for a while, and I've been avoiding it. Where did all of these things come from? So we have a very simple class called animal that has a getWeight method and a setWeight method. And now look at this, equals, getClass, hashcode, notify. Where did all of these come from? Those came from the object class. So everything in all of Java has these methods. Those are inherited from the object class. Look at this one. Well, toString was inherited from object as well, and we override it in the animal class. So there is always a toString method available because it exists in the object class. But the one in the object class doesn't really make any sense. It's not very useful, and you are expected to replace it or override it with one that does make sense for you. There's another one that you're expected to override, and it's called the equals method, and we'll look at that. These other ones, particularly the notify and the wait methods, you are not expected to override. And hash code you're expected to override if you need to, but that's in a much more advanced class than this. So we'll just ignore that one, and we'll ignore all of the notifies and the waits. And we're going to, in this class, we will talk about overriding the toString method and overriding the equals method. Okay, so the name of the class, the universal superclass, is called object, and that's a little bit unfortunate because just when you're getting to understand the difference between what a class is and what an object is, now we have a class called object. So that's unfortunate, but that's the way it's always been. So an object, small o, is an instance of a class, like Max. Max is a dog object. And object capital O is the universal superclass that has these 8 or so methods that are inherited by everything in all of Java. So here's something that I wanted to verify with you. The toString method that we wrote in animal is an override of the one we inherited from object. And the toString method that we wrote in dog is an override of the one we inherited from animal. So you inherit only from your parent. Your parent might have inherited from his parent. But each class, you think of each class as only inheriting from their parent class. Okay, to say this in a different way, because some people like to have notes and slides, all classes in all of Java inherit from the universal superclass, or the universal base class called object, capital O. All classes start with a capital letter. Object has no data members, but it has all of those methods that are inherited by all classes in all of Java, and some of them you're expected to override. In particular, the public string toString and the public Boolean equals you are expected to override. And I call this the thanks but no thanks. You got something from your parent and you don't want it because it's not appropriate for you, so you replace it by defining another method with exactly the same method signature. So let's have a quick review while we're in Eclipse, and then we'll go back and just do a summary of the things in this. We have a subclass or a child class called dog, and the parent class is animal. The relationship is a. I know you want to say a dog is an animal, but is a technical expression in OO design. So a dog is a animal. And the things in the parent class are inherited into this class. So the parent class has methods called getWait and setWait, and those are available in this class. We added only one instance variable when we extended animal, so we're saying that a dog has a name, and a dog is different from an animal in that it has a name. And of course we could add all sorts of properties to the dog and the animal, but I wanted to keep this simplest possible demonstration. Every constructor in all of Java calls the parent constructor as the first line of code in the constructor. And it's always called by using the keyword super, and you must call a constructor method that makes sense. So here's what typically happens. In the constructor for the subclass, you pass in everything that it takes to make the parent class and the subclass. So the parent class constructor, it takes a weight to make an animal, so we're going to call the constructor of the animal class and pass up the weight variable. And then all of the remaining parameters to the constructor are for making the instance of the current class. So you pass in everything it takes to make the parent object and the sub-object. The only other thing that's really new in here is you can call the methods in the parent class by using the keyword super if you've overridden them. If you haven't overridden them, you really don't need to do that. You don't need to use super. You could just call the methods as if they were right here in this class. So the methods in the parent class are inherited into the subclass. The power of this is that the things that are in the parent class we don't have to duplicate in the subclass. You might not see the power of it when we have only one instance variable and only these two simple methods. We could have easily combined these in one class, but this parent class animal is going to have several child classes, so dog and cat and bird and so on, and each time we add a subclass, we get the saving of not having to duplicate the code that gets inherited from the parent. So we made an instance of the parent class and we made sure that that was working, and then we made an instance of the subclass, and we didn't do very much testing on that, but when you say max dot, what pops up? All of the methods that you can. Let's change Max's name to Maxwell. And we changed his weight to 56 and make sure that he's still working. Well, we got an error. What happened? A semicolon. That's a good error. Okay. And you might notice 5656 because I was playing around with the toString method in the dog class, but the subclass objects have all of the methods that were inherited from the parent class. That's the point here. Quick summary of what we've looked at in this segment. Java is a single inheritance language. Each class has one parent, and child classes know about their parent, but parent classes do not know about their children. The reason for this, if you think of it, when I go back to add some more classes that are subclasses of animal, I don't want to go in and change the animal class. That would be kind of breaking the principles. We don't want to have to change everything when we make one change. So we can add stuff, or we can extend the existing classes without having to go and change the classes that are there. So that's why it's important that the children do not know, that the parents do not know about their children. If there was something specific in the parent class about the child class, then we would have to go and change the parent class whenever we added another child. The is-a relationship is used for designing inheritance, and if you say it out loud and it makes sense, then it's correct. The extends keyword is how we implement inheritance, and every constructor has a call to the parent constructor. Object is the universal superclass in Java, capital O. Everything inherits from object, and you get some methods from the object class which you are expected to override as you create your classes. And specifically, the toString method and the equals method. We looked at how to override the toString method, and we're going to do some examples of the equals method in the next segment. That's it for now. I hope you're enjoying the concept of inheritance and starting to have an appreciation of what the power of this might be.